Hi, hello, and welcome to our EduTech channel. Today we are going to see about the modern periodic table, part 2. Subscribe to our channel if you haven't yet subscribed, and follow our Facebook page at EduTechBookworm and Instagram page at EduTech_bookworm. In the previous video, we saw about the elements and blocks. In this video, we can see about the properties and its characteristics. S block. The general characteristics of S block are: they are good conductors of heat and electricity. They are malleable and ductile. It forms ionic compound. Example: magnesium bromide, sodium chloride, hydrogen chloride, calcium chloride, etc. Its oxides are basic in nature. They have low ionization potential. They form colorless compounds except chromates and dichromates. Their valency is 1 if in group 1A and valency is 2 in group 2A. That is, alkali metals have valency 1 and alkaline earth metals have valency 2. Now we can see about the alkali metals. Alkali metals is nothing but group 1 metals. They are lithium, sodium, potassium, rubidium, cesium and francium. Their atomic numbers are 3, 11, 19, 37, 55 and 87 respectively. Now we can see about the properties. Properties are classified into two types. First one is physical property and chemical property. We can see about them now. First we can see about the physical properties. First one is their physical state. They are soft, silvery white metal having a high and bright luster when freshly cut, like this. They all form body-centered lactites, which means they have a atom in the center of their body. They are soft. The softness increases with the increase of atomic number because there is a continuous decrease of metallic bond strength on account of an increase in atomic size. See here, lithium is hard in this picture, and while compared to francium, francium is very soft, but lithium is a bit hard than francium. But both are soft. The softness increases. See there, the softness increases from lithium to francium. Now, atomic size. These elements are largest in size in the period, and atomic size increase in going downwards in the group. See, lithium to cesium. See the trends from beryllium to lithium, lithium to magnesium, magnesium to sodium and sodium to calcium, calcium to strontium and strontium to barium. Then the size gets increases to potassium and then at last rubidium and cesium. See the trends of size. First, the largest in this two is beryllium, then lithium, then magnesium, then sodium, then calcium, strontium, barium, and potassium, rubidium, and at last cesium. See the order of size also. And oxidation state. These metals exhibit +1 oxidation state because it gives one electron to other element. Its density. Atomic weight increases from lithium to cesium in the group and volume also increase. But increase in atomic weight is more as compared to volume. Therefore, density increases from lithium to cesium. See the order. The density of lithium less than potassium, less than sodium, less than rubidium, and less than cesium. Here the highest density is cesium. Now bonding. As I said in general characteristics, they form ionic bond, therefore becoming cations by losing their outermost electrons. That is, they lose one electron from their valence shell. That is the last shell of their atom. Melting point and boiling point. Their melting and boiling points are low due to their weak metallic bonds. Strength of metallic bond decreases in the group from lithium to cesium, due to which hardness from lithium to cesium. See the order: lithium greater than sodium greater than potassium, greater than rubidium, and greater than cesium. Here, the highest is lithium and the least is cesium. Now we can see about the chemical properties. Reaction with oxygen. Alkali metal ignites an oxygen and form oxides. Here M is represented as metal. Now let me take M as anything. For example, we can take lithium. Lithium is ignited with oxygen to form Li2O. It is an oxide. It is lithium oxide. And then it is again burned with oxygen to get lithium peroxide, that is Li2O2. And at last it is again burned with oxygen to get superoxide, that is lithium dioxide, LiO2. Here lithium forms a stable oxide, that is Li2O. Sodium forms peroxide, Na2O2, and rest of the metal forms superoxides. It is stable, which means they also form, but it is only stable in this oxide. Lithium is only stable in oxide, and sodium is only stable in peroxide. But other metals are stable in all the properties, or not all the properties, in superoxide. Oxides of alkali metals are basic in nature, and basic character increases from lithium to cesium, which means the basic character, highest basic is cesium, as the ionic character increases, right? Peroxides and superoxides behave as strong oxidizing agents. Superoxides on treatment with dilute acids form hydrogen peroxide, oxygen, and hydroxide. Hydroxide is nothing but OH. Hydroxide is nothing but OH. See here, KO2. KO2. K is potassium. Potassium dioxide plus 2 moles of water to get 2 moles of potassium hydroxide and 1 mole of hydrogen peroxide and 3 moles of oxygen. Reaction with water. Hydrogen is liberated when 2 moles of any metal, let me take sodium. 2 moles of M, we can substitute M with sodium. So 2 moles of sodium reacted with 2 moles of water to get 2 moles of sodium hydroxide, and hydrogen is liberated as a byproduct. Then the product is substitute with Na or any metal. Basicity of hydroxide increases down the group due to increase in electropositive character. Then reaction with hydrogen. Alkali metals or alkali metal hydrates are formed when metals are heated with hydrogen. So 2 moles of sodium is heated with hydrogen to get 2 moles of sodium hydrate. Hydrates are formed, right? Then metal hydrates are ionic. They are good reducing agents. Reducing power increases down the group. When we take a francium, they have highest reducing power. Francium has highest reducing power. Reactivity with halogen. Halogens are nothing but the fluorine group. Fluorine, chlorine, chlorine, iodine, sorry, bromine and then iodine. Bromine and iodine. These are halogens. Halides or ionic compounds have a negative enthalpies of formation, which means the alkali metals react with these these halogens to form a cation, and these forms anions. This means the halogen forms anions, and the alkali metals forms cations. The most negative enthalpy of formation occur with fluorides. The negative value increases as fluorides greater than chlorides, bromides, iodides. Fluorides are most stable, and here lithium fluoride is insoluble in water due to very high lattice energy, which means their bonding is very strong, such that it can be separated when it is solute in the water, as it is not insoluble, just floats in water. Cesium, what is this? Cesium, one minute. Cesium iodide. Cesium iodide is insoluble in water due to a very low hydration energy. Rest of halides are soluble in water, except cesium iodide. All are soluble in water. Sorry, cesium iodide and lithium fluoride all are soluble in water. Metal hydroxides. The basic strength of hydroxide increase with the increasing electropositivity of metal. See here, highest is cesium hydroxide is greater than rubidium hydroxide, greater than potassium hydroxide, greater than sodium hydroxide, greater than lithium hydroxide. Now we can see, now we know that as the elements has increasing electropositivity down the group, solubility of hydroxides increase with increasing ionic character. Similarly the solubility also. Reaction with dilute acid. Due to alkaline nature, these metals react rapidly with dilute acid, and rate of reaction increases from lithium to cesium, which means cesium has highest rate of reaction, then lithium. Rate of reaction is nothing but the reaction took place in a short period of time, or in which time, in how much time the reaction has occurred, which it is said by the rate of reaction because of their increase in basic character. Alkaline earth metals, part 3. Next video on the way. Keep supporting. Follow our Instagram and Facebook page. Our Instagram page at edutech_bookworm and our Facebook page at edutechbookworm. Look at the description for links and more information. Thank you for watching. Keep supporting and share our channel. Subscribe to our channel without fail. Thank you.